All right, let's talk about something wild. What if the next computer you get isn't built, but grown? I'm talking about biocomputing. We're not talking silicon here, we're talking about circuits made of actual living cells.
Just let that sink in for a second. Imagine your own biology becoming the ultimate computer. We're talking about cells that could be programmed to, say, hunt down diseases before you even feel sick. Or, get this, even to boost your own intelligence. And look, this isn't some far-off sci-fi fantasy. It's really the direction we're headed.
So we're diving into what this living computer is all about, where life and logic literally merge. And you've got to understand, this is way bigger than just making faster gadgets. We're looking at a fundamental shift, something so big it could be the next major step in our own evolution.
Yeah, seriously, forget everything you know about silicon chips. We are talking about computers grown right in a lab, buzzing with living cells. You know, for decades, computer has meant silicon and electricity, right? Well, that whole idea is starting to change. We're stepping into a brand new era where the most powerful computers, they're not going to be built on an assembly line. They're going to be grown.
Okay, so what is biocomputing really? At its heart, it's all about fusing biological systems, things like DNA, proteins, cells, with computational logic. The goal? To process information. It's like hacking the code of life itself to make it think, to make it compute, just like a regular computer chip would.
But you might be wondering, okay, but why, right? I mean, why is this whole revolution happening right now? Silicon's done a pretty amazing job for us for the last, 50, 60 years. So why the sudden pivot to biology?
Well, the simple answer is that our current tech is kind of hitting its physical limits. You've heard of Moore's Law, right? That's slowing way down. We just can't shrink silicon forever. But biology? Biology offers a totally new way forward, especially when it comes to complexity and energy efficiency. I mean, think about this. Your brain runs on about 20 watts. That's less than a dim light bulb. A supercomputer trying to do similar work needs a massive amount of power. Nature figured out efficiency a long time ago.
So, we've gone from silicon to cells. But how does a living circuit actually work? How in the world do you get a cell to behave like a piece of a computer? Okay, let's get into the nitty-gritty.
All right, this is a really fundamental shift. In a silicon chip, everything is about the flow of electrons. That's how you get your ones and zeros. But in a living circuit, it's totally different. Information is processed using biochemical reactions happening inside living cells. Instead of electrons, the currency is, chemistry. Scientists can literally engineer a cell so that when a certain chemical shows up, a protein gets made. That's your 1. If the chemical isn't there, no protein. That's your 0. We're moving from the language of physics to the language of, life. And this isn't just an idea on a whiteboard. There are some incredible examples in action right now. You've got DNA computing, where scientists are literally using strands of DNA to crunch numbers and solve problems. Then there's protein folding. They're treating the complex shapes that proteins fold into as the output of a calculation. And maybe the wildest one, building simple circuits using actual living neurons. It's happening. And just to show you how fast this is moving, as of December 2025, researchers have already built simple logic gates using living components. Now, logic gates, those are the absolute basic building blocks of any computer. So the fact that we can make them out of living stuff, that's huge. The foundation is being laid right now. Okay, so that's the how. But what about the so what? What does this all mean for us, for society? This kicks off a whole new biological age. Let's talk about the incredible, transformative power of biocomputing.
I think medicine is where we're going to see the first and maybe biggest revolution. This is medicine's new frontier. We're talking about programmable biological therapies that can fight disease on a cellular level. Imagine hyper-targeted drug delivery with absolute surgical precision, or next-generation diagnostics that actually work inside your body 24/7. It's a total game changer.
But it goes way beyond that. We're talking about concepts that can push us beyond human intelligence as we know it. I mean, think about creating completely new forms of artificial intelligence, not just coded, but alive. This could be the key to solving humanity's most complex problems. And yeah, we have to talk about it. The potential for cognitive enhancements to our own minds. It's a lot to wrap your head around. And you know what's really cool? This isn't just about more power. It's also about creating truly sustainable technology. Our tech industry creates so much e-waste. But what if we had environmentally friendly computing systems? What about materials that are self-repairing and even self-replicating? This could lead to a whole new generation of technologies that work with nature, not against it. So where's all this headed? Are we really building our future with this stuff? Let's jump ahead and try to get a vision for, say, the year 2050.
Okay, so fast forward to 2050. A world with personalized cancer therapies and cognitive enhancements isn't just some crazy sci-fi idea. It could very well be our reality. Imagine getting a tumor zapped by a therapy grown from your own cells as just a routine thing. It's a future where this stuff is not just possible, but normal.
But let's be real. With this kind of power comes some seriously profound ethical questions. We absolutely have to talk about this. Who gets access to this tech? What does it even mean to be human anymore, if we can just upgrade our minds? This is going to take an urgent, responsible, and really collaborative effort to figure out.
So look, we are entering this incredible new biological age, and the question it puts in front of all of us is, what will we choose to become? It's a big one, and it's something we're all going to have to answer together.